December 1943. Hauptfeldwebel Otto Schmidt stood in the maintenance depot at Kursk, surrounded by 9 Tiger I heavy tanks. All 9 were non-operational. Not one destroyed by enemy fire, not one damaged in combat. All 9 broke down during the 200-kilometer approach march to the battle. Schmidt had been maintaining German armor since 1939. He'd worked on Panzer IIs in Poland, Panzer IIIs in France, and Panzer IVs in Russia. But the Tiger was different. The Tiger was Germany's answer to Soviet T-34s and KV-1s. 57 tons of Krupp steel, armed with the legendary 88mm gun that could punch through any Allied tank at 2,000 meters. The Tiger was supposed to be invincible. Instead, Schmidt watched them break down faster than he could repair them. If stories of courage and ingenuity move you, please like and subscribe. Every subscription helps us honor the memories of those who served. Otto Schmidt was born in 1915 in a working-class district of Munich, where his father ran a small automotive repair shop. By age 12, Schmidt could strip and rebuild a truck engine. By 16, he was diagnosing transmission problems his father's senior mechanics couldn't solve. When Germany began rearmament in 1935, Schmidt enlisted in the Wehrmacht at 20. His mechanical aptitude was immediately recognized. Instead of infantry training, he was assigned to the 1st Panzer Division as a maintenance technician. Poland taught him that German tanks were good. France taught him they could be great. But Russia, in 1941, taught him something else, that quantity had a quality all its own. The Soviets lost thousands of tanks, but they always had more. German panzers were superior, but each loss was irreplaceable. Then, in 1942, the Tiger arrived. Henschel and Son designed it. Hitler demanded it. The Wehrmacht believed it would change everything. Schmidt was assigned to the 502nd Heavy Panzer Battalion in November 1942, responsible for maintaining the first Tigers deployed to Leningrad. He immediately noticed problems. The Tiger weighed 57 tons, nearly double a Panzer IV. Its Maybach HL-230 P45 V12 engine produced 700 horsepower, but the transmission wasn't designed for that weight. The final drives broke constantly. The road wheels, overlapping for better weight distribution, clogged with mud and froze solid in Russian winters. But when Schmidt reported these issues to his commanding officer, he was told the Tiger was the most advanced tank in the world. Engineering would resolve minor issues. The issues weren't minor. By January 1943, the 502nd Heavy Panzer Battalion had received 20 Tigers. Of those 20, an average of 8 were operational at any given time. 60% non-operational rate. The official reason listed in reports: routine maintenance. The reality was systematic mechanical failure across every major system. Transmission problems. The Tiger's Maybach OLVAR EG 401216B transmission was a marvel of German engineering. 8 forward gears, 4 reverse, capable of handling 700 horsepower. On paper. In reality, the transmission was designed before the Tiger's weight increased from 45 tons to 57 tons during development. The final drives, connecting the transmission to the drive sprockets, experienced catastrophic failure rates. Average lifespan before failure, 500 kilometers. Time to replace, 48 to 72 hours, requiring the entire crew plus maintenance personnel, specialized tools, and a clear workspace. In combat conditions, a Tiger with a failed transmission was abandoned. Lieutenant Hans Müller's Tiger broke its transmission on March 3, 1943, during the Third Battle of Kharkov. The tank had traveled 340 kilometers since its last transmission replacement. Müller's crew had no choice but to destroy the Tiger with demolition charges and withdraw on foot. Schmidt documented it. No enemy involvement, pure mechanical failure. Engine issues. The Maybach HL-230 P45 V12 engine was powerful but fuel-hungry. At maximum load,
The Tiger consumed fuel at 8 miles per gallon, extraordinarily poor even for a heavy tank. Operational range: 120 kilometers on roads, 60 kilometers cross-country. But fuel consumption wasn't the critical problem. Cooling was. The Tiger's engine compartment was cramped. The cooling system, designed for optimal performance in German weather, overheated constantly on the Russian front during summer and froze solid in winter. Radiator failures were routine. On July 12, 1943, during the Battle of Prokhorovka at Kursk, Schmidt's battalion deployed 14 Tigers. 6 broke down from overheating before reaching the combat zone. 2 more suffered radiator failures during the battle itself. Of 14 Tigers, 8 failed mechanically. 3 were destroyed by Soviet anti-tank guns. 3 survived to withdraw. Casualties from mechanical failure exceeded casualties from enemy action.
Road wheel design. The Tiger used an overlapping road wheel design, 24 wheels per side, arranged in 3 overlapping rows. The design distributed the tank's enormous weight effectively and provided excellent cross-country mobility. It also created a maintenance nightmare. Mud accumulated between the overlapping wheels. In Russian autumn, that mud froze solid overnight. Crews spent hours every morning using blowtorches to thaw frozen road wheels before the tank could move. Worse, replacing a damaged inner road wheel required removing up to 12 outer wheels first. A task that took 30 minutes on a Panzer IV took 8 hours on a Tiger. During the spring Rasputitsa, the season of mud, Tigers were frequently immobilized not by enemy action, but by wheels so clogged with frozen mud they couldn't rotate. Parts availability. Germany produced 1,347 Tigers between August 1942 and August 1944. Henschel manufactured them at a rate of roughly 25 per month during peak production. By comparison, the Soviet Union produced over 57,000 T-34s during the same period. The low production numbers meant spare parts were scarce. When a Tiger broke down, finding replacement components often took weeks. Battalions cannibalized non-operational Tigers to keep a few running. Schmidt maintained detailed logs. In March 1943, his battalion had 19 Tigers on paper. Of those 19, 7 were completely stripped for parts. 5 were awaiting parts that didn't exist. 7 were operational. Effective strength, 37%. The weight problem. 57 tons was too heavy for most bridges in Russia. German combat engineers rated bridges, but Tigers often exceeded those ratings. Commanders had to choose between risking bridge collapse or finding alternate routes that added hours or days to movement. The weight also destroyed roads. Tigers traveling on paved roads left deep ruts that damaged the road surface for vehicles following. On dirt roads, they created muddy tracks that made movement difficult for supply trucks. More critically, the weight stressed every mechanical component. Transmissions, final drives, suspension, everything wore faster than on lighter tanks. Schmidt calculated that a Tiger required 50 hours of maintenance for every 10 hours of operation. A Panzer IV required 10 hours of maintenance for every 10 hours of operation. For elite heavy tank battalions, crews spent more time repairing their tanks than fighting. In April 1943, after Kursk, Schmidt compiled a technical report for his battalion commander, Hauptmann Werner von Stetten. The report was 9 pages of technical analysis, maintenance logs, and operational statistics. Schmidt didn't exaggerate. He presented data. Tiger 1 Technical Reliability Assessment. 502nd Heavy Panzer Battalion. Compiled by Hauptfeldwebel Otto Schmidt, April 15, 1943. Summary of key findings. Operational rate, 47% average, February through April 1943. Primary failure modes. Transmission, 38%. Engine cooling, 27%. Suspension, 18%. Electrical, 11%. Other, 6%. Mean distance between failures, 480 kilometers. Average repair time, 52 hours per failure. Strategic mobility, limited by fuel consumption, 120-kilometer range, bridge weight restrictions, road damage. Comparative analysis. Tiger 1, Panzer IV. Metric. Tiger 1, Panzer IV. Ratio. Weight. 57 tons, 25 tons, 2.3 to 1. Operational rate. 47%, 87%, 0.5 to 1. MTBF. 480 kilometers, 2100 kilometers, 0.2 to 1. Repair time. 52 hours, 12 hours, 4.3 to 1. Fuel consumption. 8 miles per gallon, 15 miles per gallon, 0.5 to 1. Production rate. 25 per month, 300 per month, 0.08 to 1. Conclusion. While the Tiger I possesses superior firepower and armor protection, mechanical reliability issues severely limit combat effectiveness. For every Tiger engaged in combat, 2 are non-operational due to mechanical failure. Current production and maintenance infrastructure cannot sustain operational requirements. Recommendation: prioritize transmission reliability improvements and expand spare parts production before expanding Tiger deployment.
Von Stetten read the report. He called Schmidt to his office. "You're telling me the Tiger is unreliable?" "Hauptmann, the Tiger is the most powerful tank on any battlefield, but 50% operational rate means half our strength is always unavailable. We cannot sustain offensive operations with those numbers. The Tiger has been designated our primary heavy armor. The Führer himself approved this design." "Yes, sir, but battlefield reality doesn't match Berlin's expectations. Every Tiger we lose to mechanical failure is a Tiger we can't replace. The Soviets lose 5 T-34s for every one we destroy, but they build 50 replacements. We lose 1 Tiger to a broken transmission and wait 6 weeks for parts." Von Stetten placed the report in a folder. "I'll forward this to Army Group Center. But Schmidt, the Wehrmacht doesn't admit failure. If the Tiger has problems, we fix them. We don't abandon the platform." "I'm not suggesting we abandon Tigers, sir. I'm suggesting we address systematic reliability issues before they cost us more tanks than the enemy does." "That decision is above both our ranks. Maintain what we have. Do your best." The report was forwarded through channels. Schmidt never received a response. June 1943. Operation Citadel, the German offensive at Kursk, was the largest tank battle in history. The Wehrmacht assembled 2,700 tanks and assault guns, including 147 Tigers distributed among heavy tank battalions. The 502nd Heavy Panzer Battalion received orders to move from Orel to the Kursk salient, 200 kilometers south. Schmidt's battalion departed with 15 operational Tigers on June 30th. The plan was to travel by rail to conserve operational hours and fuel, but partisan activity had damaged rail lines. The Tigers would drive. 200 kilometers, 4 days of movement. July 1st, Day 1. The battalion covered 60 kilometers before dark. 3 Tigers broke down. Tiger 213, transmission failure at kilometer 48. Tiger 221, engine overheating at kilometer 52. Tiger 234, final drive failure at kilometer 59. All 3 were towed to field maintenance positions. Crews estimated 48 hours minimum for repairs. The battalion continued with 12 operational Tigers. July 2nd, Day 2. Weather turned. Heavy rain converted roads to mud. The Tiger's weight created deep ruts. Supply trucks couldn't follow. Fuel trucks were delayed. At kilometer 110, Tiger 231 threw a track in thick mud. Recovery took 6 hours. By evening, the battalion had covered only 45 additional kilometers. 2 more Tigers broke down. Tiger 207, road wheel damage, inner wheel cracked. Tiger 242, electrical failure, starter motor burned out. 10 operational Tigers remained. 8 were non-operational at field maintenance sites 80 kilometers behind. July 3rd, Day 3. Schmidt's maintenance crews were exhausted. Each evening, every Tiger required inspection, track adjustment, fluid checks, and minor repairs. The overlapping road wheels needed cleaning to prevent overnight freezing, even in summer dew. At kilometer 165, Tiger 219 suffered catastrophic transmission failure. The final drive simply disintegrated. Metal fragments destroyed internal gearing. The tank was immobile and unrepairable in field conditions. The crew had two options: wait for heavy recovery vehicles that might arrive in days, or destroy the Tiger and continue on foot. They destroyed it with demolition charges. One Tiger lost, not to enemy action, to mechanical failure. Two more broke down before evening. Tiger 228, fuel pump failure. Tiger 251, suspension collapse, torsion bar snapped. 7 operational Tigers remained out of the original 15. July 4th, day 4. The battalion reached the staging area near Kursk with 7 Tigers. 8 had broken down en route. 0 had been damaged by enemy action. Operational rate after 200 kilometers, 47%. Schmidt reported to von Stetten. 7 Tigers arrived. 8 require recovery and repair. Estimated time to restore battalion to full strength, 2 weeks, assuming parts arrive. Von Stetten looked at the 7 Tigers that made it. These 7 will have to be enough. Citadel begins tomorrow.
Sir, these 7 have traveled 200 kilometers. They need full maintenance. Transmissions should be inspected. Road wheels need replacement. These tanks are one major failure away from... We attack at 0500. Make them ready. Schmidt and his crews worked through the night. The 502nd Heavy Panzer Battalion entered combat on July 5th with 7 operational Tigers. July 5th, first day. All 7 Tigers engaged Soviet defenses at Poniri. The 88mm gun proved devastating. Tigers destroyed 18 T-34s and 7 KV-1s at ranges exceeding 1,500 meters. Soviet return fire bounced off Tiger frontal armor. But by evening, Tiger 203, transmission failure during maneuver. Tiger 246, engine overheating, radiator damage. 5 operational Tigers remained. July 7th, third day. The Tigers advanced toward second defensive line. Schmidt's maintenance crews worked continuously, performing emergency repairs under fire. Tiger 209, final drive failure during advance. Tiger 237, track thrown, outer road wheels damaged. 3 operational Tigers remained out of the original 7. July 12th, 8th day. The Battle of Prokhorovka. The 502nd Heavy Panzer Battalion deployed 3 Tigers alongside other German armor for the massive tank battle. Soviet forces deployed over 800 tanks. German forces deployed roughly 600, including the 3 surviving Tigers. All 3 Tigers fought effectively. Their 88mm guns destroyed 11 Soviet tanks at long range. Soviet shells couldn't penetrate Tiger frontal armor. But during the battle, Tiger 205, transmission failure during evasive maneuver. Tiger 214, engine fire, fuel line rupture. 1 Tiger remained operational by evening. Oberlieutenant Klaus Fischer's Tiger 223. Of the 15 Tigers that departed Orel on July 30th, 1 remained operational on July 12th. Operational rate 6.7%. Schmidt compiled post-battle statistics for Operation Citadel. 502nd Heavy Panzer Battalion, Kursk, results. Tigers deployed, 15. Tigers destroyed by enemy, 3, or 20%. Tigers lost to mechanical failure, 11, or 73%. Tigers operational at battle end, 1, or 7%. Casualties by cause. Transmission/final drive, 6 Tigers, or 40%. Engine/cooling, 3 Tigers, or 20%. Suspension/tracks, 2 Tigers, or 13%. Enemy fire, 3 Tigers, or 20%. Electrical,
1 Tiger, or 7%. Combat effectiveness. Soviet tanks destroyed, 47. Kill ratio, 3.1 to 1 when operational. Average operational time, 4.2 days. Average time non-operational, 9.8 days. The data was undeniable. Tigers killed effectively when they worked, but they spent more time broken than fighting. More critically, mechanical losses exceeded combat losses by nearly 4 to 1. Schmidt added his own conclusion to the report. The Tiger is invincible in combat when it reaches combat. But for every Tiger fighting, 2 are broken. Transmission lasts 500 kilometers before failure. Replacement takes 3 weeks. Meanwhile, American Sherman runs 5,000 kilometers and is repaired in 1 day. War is not won by perfect tanks that don't move. War is won by good enough tanks that keep moving. This report, like the April report, was forwarded through channels. This time, Schmidt was called to Berlin. August 1943. Schmidt was summoned to the Reich Ministry of Armament and War Production in Berlin. He expected reprimand for criticizing Germany's premier heavy tank. Instead, he met General Oberlieutenant Heinz Guderian, Inspector General of Panzer Troops.
Guderian was a legend, the architect of German blitzkrieg, the man who proved armored warfare could decide campaigns. He'd read both of Schmidt's reports. Hauptfeldwebel Schmidt, your reports suggest the Tiger is operationally deficient. General Obrist, the Tiger is the most powerful tank on Earth, but power means nothing if the tank cannot reach the battle. Guderian gestured to Schmidt's reports on his desk. These statistics, are they accurate? Yes, sir. Every number verified through maintenance logs and battalion records. 47% operational rate, 73% casualties from mechanical failure at Kursk. Guderian paused. The Tiger is Hitler's favorite weapon. Production is expanding. We're developing the Tiger II, even heavier, even more powerful. Sir, with respect, more weight will worsen reliability problems. The Tiger II will break down more frequently than the Tiger I. I agree. Schmidt blinked. Sir? I agree completely. The Tiger is an engineering masterpiece that cannot be maintained in field conditions. It's too heavy, too complex, too fuel-hungry. Every Panther tank, our medium tank, has the same problems. We're building vehicles that excel in testing grounds but fail in Russia. Guderian stood, walked to a map of the Eastern Front. Here's what I know, Schmidt. Germany produces 25 Tigers per month. The Soviet Union produces 1,200 T-34s per month. America produces 2,000 Shermans per month. We're fighting a war where quantity matters more than quality. But we keep building quality we can't sustain. Then why? Because Hitler demands it. Because Henschel and Porsche compete for contracts. Because the Wehrmacht wants invincible superweapons. Your reports are correct, but political reality overrides mechanical reality. Schmidt felt the weight of futility. Then the reports accomplish nothing. No. Your reports document truth. After this war ends, and it will end, historians will ask why Germany lost. Your reports will show them. We lost because we built 1,347 Tigers that spent most of their time broken. We lost because we prioritized engineering perfection over operational reality. Guderian returned to his desk. Continue your work, Hauptfeldwebel Schmidt. Maintain what you can, document what you cannot. The Wehrmacht needs more mechanics like you, men who understand that wars are won by logistics, not firepower. Schmidt saluted. Yes, General Obrist. He returned to the 502nd Heavy Panzer Battalion. By September, they'd received 4 replacement Tigers. By October, 2 were non-operational. The United States captured its first Tiger in Tunisia in February 1943. American engineers immediately shipped it to Aberdeen Proving Ground in Maryland for analysis. Their report, classified at the time, reached conclusions similar to Schmidt's. Preliminary report, German Panzerkampfwagen 6, Tiger. Aberdeen Proving Ground, June 1943. Summary. The Tiger Eye represents the peak of German armor design philosophy. Heavy armor, powerful gun, sophisticated engineering. Advantages: 88mm gun, superior to any Allied tank gun. Armor: frontal protection impervious to standard anti-tank weapons. Accuracy: excellent fire control systems. Disadvantages: weight: 57 tons creates mobility and logistical problems. Complexity: requires extensive maintenance, specialized tools. Reliability: transmission and final drive failures common. Production: low production numbers limit battlefield impact. Fuel: range limited to 120 kilometers, requires constant refueling. Conclusion: the Tiger is a formidable weapon in favorable conditions. However, mechanical complexity and low reliability make it unsuitable for sustained operations. American doctrine emphasizes reliable, mass-produced armor over individual superiority.
Recommendation: continue M4 Sherman production. Accept armor inferiority. Compensate through numbers, reliability, and superior logistics. The American approach was diametrically opposite. Build good enough tanks that worked consistently. Sherman operational rate 90%. Tiger operational rate 47%. On paper, one Tiger equaled 5 Shermans in combat effectiveness. In reality, 5 Shermans were always present. Half the Tigers were in maintenance depots. As the war progressed, Tiger reliability worsened. Parts shortages. Allied bombing destroyed German factories. Spare parts production collapsed. By late 1944, Tigers were cannibalized for components. Battalions stripped 3 non-operational Tigers to keep one running. Fuel crisis. Germany's fuel supplies dwindled. Tigers, with their 8 miles per gallon consumption, were prioritized for fuel allocation. But even priority allocation wasn't enough. Tigers were abandoned with working engines because fuel trucks couldn't reach them. Crew exhaustion. Experienced crews were killed or transferred. Replacement crews lacked training. Poorly trained drivers overstressed transmissions. Poorly trained mechanics made mistakes during repairs. Strategic retreat. Germany fought defensively from 1944 onward. Tigers excelled in defensive positions, using their long-range guns and heavy armor. But defensive warfare required mobility to reposition. Tigers couldn't move fast enough or far enough. During the Normandy campaign, entire Tiger battalions were destroyed not in combat, but during retreats. Tanks broke down. Crews destroyed them to prevent capture. Of the 1,347 Tigers produced, more were destroyed by their own crews than by enemy action. May 1945. Germany surrendered. Schmidt was captured by American forces near Munich. During interrogation, American intelligence officers recognized his name from captured German reports. They asked him to write a comprehensive technical assessment of the Tiger tank. Schmidt spent 3 weeks writing his final report. 50 pages of technical analysis, operational statistics, and brutal honesty. The report concluded, "The Tiger I was Germany's attempt to win through technological superiority. It failed because war is not won by superior weapons. War is won by logistics, production, and reliability. The Tiger killed more enemy tanks per engagement than any Allied vehicle, but it spent more time non-operational than operational. A weapon that cannot reach the battle is not a weapon." Germany built 1,347 Tigers over 3 years. The Soviet Union built 57,000 T-34s over the same period. America built 49,000 Shermans. Quality cannot overcome quantity when quality is unreliable. The Tiger's greatest enemy was not Allied tanks, it was German over-engineering. We built a tank so complex it couldn't be maintained in field conditions. We built a tank so heavy it destroyed its own transmission. We built a tank so expensive we couldn't produce enough to matter. The Tiger didn't lose the war, but it didn't win it either. And that's the same thing. Schmidt returned to Munich in 1946. He reopened his father's automotive repair shop, which had been damaged during Allied bombing. He never spoke publicly about his wartime service, but he kept copies of his reports: the April 1943 analysis, the Kursk statistics, the August meeting with Guderian, and his final American interrogation report. In 1952, a British military historian researching tank warfare contacted Schmidt. The historian, John Milsom, was writing a comprehensive history of German armor. He'd found references to Schmidt's reports in captured Wehrmacht files. Schmidt agreed to an interview. He provided Milsom with detailed technical information, operational statistics, and personal observations. That interview became the foundation for Milsom's assessment that the Tiger, despite its fearsome reputation, was operationally deficient. Schmidt's conclusion, delivered to Milsom in 1952: people remember the Tiger as invincible. They remember the 88mm gun, the thick armor, the terrifying reputation. They don't remember that half were always broken. They don't remember the hours spent repairing transmissions while Soviet tanks advanced. They don't remember crews destroying their own Tigers because they couldn't move them. The Tiger was a symbol of German engineering pride, and that pride cost us the war. We built weapons for testing grounds, not battlefields. We built weapons that impressed generals in demonstrations, then broke down on muddy roads. The Americans understood what we didn't. A good tank that runs beats a perfect tank that doesn't. 5 average tanks defeat 1 excellent tank that's in the maintenance depot.
If I could tell one thing to future tank designers, it would be this: reliability is a weapon. Simplicity is armor. Logistics wins wars. Otto Schmidt died in 1978 at age 63. His obituary mentioned his wartime service, but not his reports. Today, those reports are studied at military academies. The Tiger tank paradox, devastating when operational, unreliable in practice, is taught as a lesson in the dangers of over-engineering military equipment. Modern tank designs prioritize reliability and maintainability. The M1 Abrams, Leopard 2, and Challenger 2 are designed for 90+% operational rates. They're built to be repaired in field conditions with standard tools. The Tiger taught that lesson the hard way. The numbers in retrospect. Production: Tigers, 1,347 total. T-34s, 84,000 total. Shermans, 49,000 total. Operational rates: Tiger, 50% average. T-34, 75% average. Sherman, 90% average. Combat effectiveness, kills per loss: Tiger, 5.1 to 1. T-34, 1.8 to 1. Sherman, 1.2 to 1. Strategic impact: Tigers destroyed, 9,000 Allied tanks estimated. T-34s destroyed, 80,000 Axis vehicles estimated. Shermans destroyed, 45,000 Axis vehicles estimated. The Tiger killed more efficiently, but T-34s and Shermans killed more in total because they were always present. A tank that kills 5 enemies but is only available 50% of the time achieves 2.5 kills per unit. A tank that kills 2 enemies but is available 90% of the time achieves 1.8 kills per unit. But when you produce 50,000 of the reliable tank versus 1,300 of the efficient tank, the math becomes overwhelming. 50,000 times 1.8 equals 90,000 kills. 1,300 times 2.5 equals 3,250 kills. Quantity multiplied by reliability
defeats quality undermined by complexity. Otto Schmidt understood something the Wehrmacht command never fully accepted. That complexity is a liability in warfare. The Tiger I represented the pinnacle of German engineering, a tank so powerful it could dominate any battlefield it reached. But reaching the battlefield was the problem. Schmidt's reports documented what every maintenance crew knew. More Tigers were lost to broken transmissions than enemy fire. More Tigers were abandoned during retreats than destroyed in combat. More Tigers sat in maintenance depots than fought on the front line. The Tiger's failure wasn't in design, it was in philosophy. Germany built weapons for perfection. The Allies built weapons for reality. Schmidt tried to warn them. He compiled the data, wrote the reports, briefed the generals. He showed that a 47% operational rate meant strategic paralysis. He demonstrated that complexity was the enemy's best weapon. No one listened. After the war, military strategists studied Schmidt's reports and reached unanimous conclusions. Reliability matters more than firepower. Simplicity matters more than sophistication. And quantity multiplied by consistency defeats quality undermined by fragility. The Tiger was invincible in combat, but it couldn't reach combat reliably enough to matter. Schmidt's 9 pages of data told the truth that propaganda couldn't. Germany lost the war in depots, not on battlefields. Final statistics. 1,347 Tigers produced over 3 years. 47% average operational rate across all theaters. 73% of Kursk casualties from mechanical failure. 500 kilometers average transmission lifespan. 52 hours average repair time per failure. More Tigers destroyed by crews than by enemy action. If you found this analysis valuable, please like and subscribe. Share your thoughts in the comments. What other over-engineered weapons failed due to complexity? Where are you watching from? Thank you for watching this deep dive into one of World War II's greatest strategic paradoxes.